So we are studying area between curves still, correct? I intended to show you this yesterday and forgot. So today is the day. So this is kind of an illustration, and it'll show you why we call this accumulation. Okay, when you go to the study session next week, it's titled Accumulation Area under a Curve. Okay, because if we're looking at these two curves, we have 5 minus x squared and x minus 1. If we want to find the area between these two curves, it's top minus bottom, correct? As in yesterday. And our x values probably from -3 to 2. It's called accumulation because integration is the process of counting up all of those areas from left to right. We're accumulating area. That's why it's called accumulation. But this just is it's a good illustration of what you're actually calculating. So that one I think you got yesterday. It seemed to me you were fairly comfortable with it. Here's a different one. Okay, I showed you this yesterday as well, where they switch position, right? So we have this region, and then they switch position, and this region. So we have to split it into two integrals, correct? Okay. One integral would be from -1 to 0, and then we would go from 0 to 3. And then you can see that top minus bottom, and then it switches position, and you accumulate the area. Okay. And if you want, this actually accumulates the area there too. No, it doesn't work quite right. You can see how the integral limits move. This would be a similar example. Sine x and cosine x. We're just having this same examples here. Again, more curves. Okay. If you need a picture, you can graph them. What I want to show you is integrating along the y-axis. Okay. Now, it's not a big deal. If everything's in y, it's the same process. It's just right minus left. So let's take a look at those. So all you're doing, if you look at the function, this function would be y equals 1/4, or x to the 1/4. Okay. Fourth power everything, you get x equals y to the 4th, correct? And the bottom one is the square root of x negative x plus 2. You just move everything into the y to x equals, and it gives you everything in terms of y. So possibly, I'll show you. So the integration, it switches spots. Okay, instead of left to right, it's bottom to top. But you still get the same conclusion. This would in effect be our top curve or our right curve, and this would be our left. Okay? So right minus left. So let's do a couple of those. Yeah? Sometimes you're given it in terms of y, no problem. Sometimes you're giving it in terms of x, and you have to switch gears. So think. On this, or this one. So can you see, the reason we need this is because sometimes things don't work on the x-axis. Okay, can you see how this would not be possible on the x? Right? There's no way for us to do a top minus bottom calculation for the x-axis. Okay. But for x, the positives are up here, correct? Over here, positives. Okay. So positives top minus bottom, positives are right minus left. So if you're integrating with respect to y, it's right minus left. And then it will be in terms of y. What you're doing is moving that area from, and everything's in terms of y, so it doesn't mean, there's no like implicit differentiation or anything here. It's the same process, you just have a y instead of an x. So I'm saying there's nothing like that. So a lot of people get like freaked out by this. So let's do an actual example, and I think you'll be okay. So we're going to calculate the area enclosed by these two graphs. And matches the rest of the town, right? Oh, that's right, of course. That's right, radiation states, right? Okay. How do I calculate where they intersect? We were not given an interval, so we need to calculate where those intersect, correct? Yeah. Okay, so we need the intersections. Is that equal to each other? Oh, this is subtract and add over, right? The y squared disappeared, thankfully. We've got no mean quartic to solve. Subtract 2. Oh, yeah, see, something's not right here. We know for positive 16. Subtract 2 times negative 8. And then fourth root. even root, you got to consider that negative case. Okay, so we found the intersections. We know this is where we're headed. Which one's the right curve? This is akin to figuring out which one's top and bottom, so you need to know which one's right. I just do 0. So we know there are only 2 intersections. Okay, so G is the right curve. And it should be because it's positive. So we have right minus notice everything's in terms of y. There are no x's floating around here, so we're not going to have any issues. Y squared minus y squared. And 1 minus negative 1 is plus 1. And we already did that actually. It's the same thing as that.
Wait, what do you mean Q?
I said it's the same and I wrote it right here. Integrate. Logan McClung, integrate. Right, negative. Plus y, and we're evaluating from negative 2. Negative 1/4 y to the 5th. This 1/8 over 5 is 1/4. Now plug in Chuck. We plug 2 in. Negative 32 over 40, right? Plus 4. Minus 32 over 40 minus 4. You can finish your math there, right? Again, pre-response, what do we do? You can stop. Okay? Stop, because we have a numerical answer at this point, and all you can do is screw it up. You're looking at the graph here. It looks something like something like that. It's not perfect, but that's what you're doing. So, integrating with respect to y, you're basically just taking the axis and rotating it. Everything's in terms of y, so you're good. Okay. Questions? Let me see if there are any here that I put on there that are not in all terms of y. Just to make sure. Seven's good. 5. It's good. Okay, so I'm not throwing anything where you have to transfer it from X to Y at you yet. So we're done. What? Oh, that's right. Be gone!
Now you're like 4 minutes late.
Yeah, she was enjoying herself. She was happy. Okay, I'll write the assignment down. You have the rest of the hour to work on it. Okay? Same yesterday. All right. I can come there real fast. I'm not going to stay long.
Okay. I just have to.
In October. Midway through
She was hard to read.
She was. She would like say something like, "Are you serious?" I don't know how to tell.
Can you give me a sign here?